the periodic table has many trends or patterns in them that is important for us to be able to recognize, so that way we can look up the information easily. So here in this lecture, I'll be discussing two of the most important periodic trends. First is the one in atomic size, and second, the trends in ionization energies. So now let's discuss the trends in atomic size. Here are the size of the different atom right here, and by size we are referring to the radius of the atom. And you will be surprised to see that in fact when we look at element on the same period, for example element on the second period, as we go from left to right, we see that the elements are getting heavier and heavier, right? We can have more proton, more neutron and electron in their electron cloud. However, we observe that when it comes down to the size of the atom, the size is actually decreasing as we go from left to right, so it gets smaller. And this is something many students find a little bit confusing right here, but then it will make perfect sense when we go over this in more detail in a little bit. And the other pattern that we're seeing right now is as we go from top to bottom, then clearly we see the elements are getting bigger and bigger. And this makes sense right here because as we go from top to bottom, the elements are getting bigger, and therefore the size are also increasing as well. But how do the elements get smaller as we go from left to right across the period? So now let's go over it. So we observe again the size decrease going from left to right or across the periodic table. And the reason why is as follows. Element on the same row have the valence electron on the same principal shell. So it's first important that we recognize that. For an example, electron in the case of lithium, its valence electron located on the second principal shell. So this is why the electron configuration is ending with 2s1, and for Be it is 2s2 and so on. So in this case right here, we will then see that all of these elements right here have the valence electron on the same principal shell. But here's what happened. As we go from left to right, we can then see that the number of protons on the element on the right side are increasing. So the valence electron at the same principal shell. However, the number of protons in the nucleus are increasing. And because the protons are positively charged, so therefore they can attract the electron on the second principal shell better, therefore pulling those electrons closer to the nucleus. And as the consequence, the size for element on the right side then becoming smaller. So that is the explanation why. And again, let's go over this again to make sure we understand this. So first, element in the same principal shell have the valence electron located on the same principal shell. But because the atomic number or the number of protons are increasing as we go from left to right, and therefore the nuclei are becoming more and more positive on the right side, and that way can attract the electron cloud much better, therefore pulling the electron cloud closer to the nucleus, and thus the size becoming smaller. And now it's easy for us to understand why the size would increase going from top to bottom or down the period. Because as we go down from one period to the next period, the atom now have more principal shell and so on. So therefore it would make sense that the size of the atom would also be increasing as well. And now let's summarize the atomic radius used by drawing this on this table over here. So we can see the size is actually decreasing. So in this case it is decreasing going from left to right, and it increasing going from top to bottom. So that's how it is. And now, let's now go over the second trends, the trends in ionization energy. So first, let's define what ionization energy is first to make sure we understand what it is. So ionization energy, by definition, is basically the energy required to remove a valence electron from the neutral atom. So the electrons are actually attracted to the nucleus electrostatically, and therefore in order for us to remove an electron from an atom from ion or a cation, then we need to add in energy to overcome the attractive force between the valence electron and the nucleus. So the first ionization energy is basically the energy needed to remove the first electron from the atom, whereas the second ionization energy is the energy needed to remove the second electron. And the third ionization energy would be the energy needed to remove the third electron, and so on. But then that's what ionization energy is. Energy they needed to remove an electron from the atom. And here are the pattern of ionization energy right here. The ionization energy increases going from left to right. So this tells us the element on the right side would require more energy to remove the electron. Versus, and the other one that we see, that ionization energy decrease going from top to bottom. So basically, for element on the bottom, it will require less energy to remove an electron from it compared to element on top. And the explanation for this is as follows. And this actually follows the same trends compared to the atomic side. Element on the right side of the periodic table, because they're smaller, so therefore the electron are closer to the nucleus. So thus it requires more energy in order to overcome the attractive force between the electron and the nucleus. So that is basically the explanation why. And this is directly correlate to the trends in atomic side. So again, element on the right side are smaller, so therefore the electron, the valence electron, are now much closer to the nucleus and thus become more difficult to remove. And as for the statement B over here, the reason why the ionization energy decrease from top to bottom is that for element on the bottom, the valence electron are now further away from the nucleus. And because it's farther from the nucleus, therefore it will require less energy to be able to remove it, and thus have lower ionization energy. And if we were to basically look at this table right here, then what this is saying, for any of the period, the left element on the left side will have less ionization energy, and the element on the right side will have more energy to it. So this is this is hydrogen, and this is helium. And here will be element for the second period right here. Lithium have lowest ionization energy, and neon have highest ionization energy. And moving on to the third period, then sodium have lowest ionization energy. And as we go from left to right, argon now have the highest ionization energy. And same thing on the period 4. Sodium, potassium have the lowest, and krypton have the highest. So the noble gases on each of the row would have the highest ionization energy. So we can summarize this as follows. When it comes down to the ionization energy, it is increasing going from left to right, and it actually decreasing going from top to bottom. So these are the two most important periodic trends that students need to be able to understand at this point.